Hello, today I'm gonna review the new ChatGPT 01 Mini, which is apparently the new super strong coding AI. And we're gonna do this by asking it to optimize my graph render code and my Mario 64 mod. So this is my prompt. Help me optimize my graph render code for my N64. N64 uses a MIPS R4300i. And number one thing we want is data throughput. We want small code, few memory reads. CPU cycles is secondary. We're telling it we're using GCC OS, and we're explaining real quick that the graphic render system computes the matrix and orders the display lists. So next snippet will contain the code. So apparently this has like a reasoning module. It's great, blah, 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 blah. Okay, I don't care about all this. What? All right, cool start. Let's give it the code snippet. So we needed to understand what all these macros are. So let's tell it. This function computes the sine and cosine and returns them into separate float racks using the complex number extension. We use the absf macro, which compiles to the abs.s instruction, and we use a cf macro which compiles to elui/mtc1 instead of the lwc1 that GCC would usually compile. Can you optimize this ? Lots of words I just said that many people, I imagine, do not understand. Let's see what ChatGPT makes out of it, if it can understand what I'm talking about. Revisiting the if statements, potential optimization, reusing operations, refining the new angle. Oh, cynics, maximizing efficiency, testing optimization. Okay. Just so we know exactly what we're talking about. The Sincos function is the BC instructions. AC actually. All right, let's see what it's got. That's a lot of text. Current overview. Polynomial. Yeah, they got that right. Yep, that's true. Doing a redundant operation. Remove the absf macro. Since new angle is always non-negative. Abs angle is masked with 7 FFF and new angle. But we add 2000 to it. The absf operation is redundant. Okay. Let's remove the absf operation. See what happens. I mean, if it's redundant, shouldn't GCC compile that out? It's one instruction less. If it works, it works. Well, that was horrendous advice. It clearly does not work. The sine cosine is used to compute the rotation of Mario's bones, by the way. So I know this optimization did not work. All right, that is one mistake already. Minimize constants. Each CF macro likely translates to in the sequence. Minimizing the number of distinct constants can reduce the number of load sequence. Current constants are these three. Yep, looks right. Certain constants can be expressed in terms of others or reused. You can reduce the number of CF calls. However, in your case, the constants are distinct necessary for the operation, so I have limited gains. Yeah, you can't do that. Branches with arithmetic operations. Pipeline stalls where possible, replace conditional logic. Swapping syntax. Use mask to conditionally swap without branching. This is an interesting concept. Unfortunately, you're doing integer math on floating point registers, which will incur an MFC1 and MTC1 penalty. So this will be worse. I don't even need to test this. Using science without branching. Again, you're using integer math on floating point registers, which will be slow. Inline function optimization. Okay, CF is inlined. I'll just tell it. You are using integer math on flow tracks. This will incur an MTC1 and MFC1 penalty, making this slower. Branches are also no issue because there is no branch prediction here, so don't worry about those. They are just one cycle. CF is already inlined. Apps F is already this. Yes, I told it that. Why isn't it listening to me? Does it think I'm stupid? All instructions, sure. Reduce register pressure, reuse register, okay. Also, apps F is not. Don't forget that the mistake made at the beginning. Redundant because the number might turn negative after. Where does it turn negative actually? After subtracting shifter? Subtracting shifter from it. Just so you have the context, this is what it does. It said new angle is always positive. It's not, because shifter can be negative. Heat changes. Yeah, I was wrong on everything. Cool. Let's see if it can come something up. Let's see if it can come up with something else. Otherwise, I will be moving on to the next function. This is a very difficult one to understand and optimize though, so I don't blame it. Like this is, I feel like if you showed this to a normal programmer, he wouldn't even be able to understand what I just showed him. IS-Spec 3? What the fuck was that? Mapping the sequence, evaluating code. Oh my god, that types so fast. It's using a struct? No! Wait, what? Oh, it thinks the F3D, it thinks the F32 times 2 is a struct. It's not. Okay, let's see. What's different here? Apps angle is the same, shift is the same, new angle is the same, new angle F is the same. It generates them once instead of just doing it in code, so this is just more separated. New angle square. Okay, this is also just separated. Sin x is new angle F multiplied by approx 1. That's already what it was. Approx 2 is approx 1 by approx 1, which it already was, multiplied by C3. Minus C4, that's already what it was. And then this is what it was, this is what it was, this is what it was. I made no changes. Final optimization with explanations. Okay, is this where the changes are? Okay. It didn't make a change. All right, well, I'm just gonna assume it's perfect then. Let's do the next one. This function takes a float. This is a MTXF to MTX. This function takes a float 4x4 matrix and has to convert it to a 16 matrix that is 4x4x2, with the first 4x4 being the high bits and the later 4x4 being the low bits. We can assume the last, what is this? Is this row or column? I keep forgetting. Row versus column. Let me Google this real quick. Row versus column. Column is a vertical, okay. The last 4x1 1x4 column can assumed to always be 0, 0, 0, 1 in the float matrix and should be output as that in the int matrix. Let's see. Do while is faster, so I hope it can do that. The reason do while is faster is because it can assume that you will do the loop at least once, so it doesn't have to do the branch at the beginning, it can just do it at the end. That's why this is like this. Although I feel like you could have already assumed this from the get-go, and this is just GCC being suboptimal. But you know, you might as well do the work for GCC. So it is what it is. Yeah, this is also like extremely fucked to look at. And then there's this too, which is like a cache invalidation for 4 cache lines, which I don't think it will understand. But hopefully it just ignores it or keeps it around, as long as it doesn't try to do anything with this. Okay. Matrix variant validation, yep. Well, it doesn't really choose. At runtime, it doesn't compile time. Iterations, paired iterations, read, scale. It knows it's scaling, that's good. Too low, yep. Finalize the matrix, yes. Loop efficiency, reduce the number of temporary variables, minimize redundant calculations within the loop. I don't think that's possible. Combine multiple bytes where possible. Yeah, we do some of that with writing the zeros at the end. Interesting. I'll be honest, man, I have no idea what this is. Will just put this in, compile it, see what happens. I need all of the code, actually. My bad. 2868. 1 instruction more. It failed. It made it worse by 1 instruction. Does it work though? It works. I mean it works. It's worse, but it works. Which is good, actually. Like, wait. Is it the same instruction count and I just fucked up? Why am I at 2A6C now? This should be it, right? Okay, somehow I just got 1 instruction more, which I don't know where it came from. It must be something else I did. Okay, we'll not worry about this for now. It doesn't matter. So it produced the exact same code. It just gave me back my code. I guess we can just move on then, if it just gave me back my own code. Oh wait, there's a final optimization here. Alright, I will just take this, put it here, see what happens. 2A6C, same code. Okay, cool. Is there any difference here actually? The end is just dest plus 16, dest high, dest low. Okay, well, we don't actually deal with dest high and dest low because this is just, now we have to increment both pointers instead of 1. Yeah, it's the same thing. Alright. Alright, next code. I don't want to waste tokens for nothing. So a function like this, we probably didn't need to put in there. Same with this. This feels like maybe something can be done. All right. So this function converts a segmented address into a lem address. Try to optimize this. Maybe it can come up with something. I don't think it's impossible. You never know. It's very hard to prove that a code cannot be optimized anymore. Especially if you have assembly available to you. Minimize casting. Guess the assumed by once and we use the casted value. Well, it's gonna do that. Key optimization command. In a single return statement, and that won't make a difference. Register allocation, inline assembly version. Okay, inline assembly version. I like the sound of that. Let's see the C version first. Same. Inline assembly version. All right. Bro is speaking my language. Operand 3 out of range. All right, before we actually go through with figuring out how to make this inline assembly work, let's actually think about that. Wait, I don't have a separate version of this. Let's just look at this. Okay, SRL looks fine. Andy T1%1. That's the A0 register, I guess. So that's just A and 0x bunch of Fs. SLL by 2 makes sense because we want to convert to the pointer index. T2, T0, T %2. What the fuck is %2? Is this just like segment table? Okay, yeah, so it adds to the value of segment table. This will be a Louis, and no, actually it should get the segment table before, and it will be a GP. So this should just be add GP something. Actually, it might not. I think this will actually be an extra instruction because it has to add to GP to get as a segment table to pass into this. And then we're reading from 0 here, which is a problem because you want to read from %high to and then %low to from T2 here. So I think this will be one extra instruction. T3, T1. T1 is good. Ori, yeah, that's fine. It's WT4. Result is T4. Yes, but this actually makes me think of something else. Why do we even need this? What if we just change the segment table so that every time we read from the segment table here, I'll just go back to my code, I prefer this. So it's like a base address, that's not what we need. What if we just end with one FFF here and keep the address? Wouldn't that be faster? Like we do this, and then we remove this. Where else do we use this? This is fine. We don't need this anymore. We don't need this anymore. And we don't need this anymore. No? Is this not just better? 2A6C, 2A50. That's a 7 instruction improvement. Well, that would would do it. So I'm sure this optimization is possible, just not like this. Yeah, I'm gonna do this after this video here, because this is not actually related to what I'm doing. Just a good idea I had just now. Let me see, are we back to normal? Is there another thing I'm missing? Probably. I don't think I reverted all of it. Well, the game runs again. That's good enough for the purpose of this video. We make a note. Segment 0x800000 optimization. I will do that after I'm done with this video. Alright, next we have toggle AA on the L. This would be a nice one to optimize. This would be very nice if we could. So let's ask it. What it did here is rubbish, I'm pretty sure. This function here iterates over a display list with display list, which is what the game reads to render graphics, to toggle anti-aliasing on or off. Help me optimize this. One obvious or one seeming optimization here would be a default unreachable thing, but we can't do that because it's not actually unreachable. But I wonder if it will come up with this. All the bit magic here, I don't want it to touch that, so I'm not gonna tell it what those bits are. I mean, I don't really see how it can optimize this. Is there maybe something better than while one, like do while one? Surely that's compiling to the same thing. Right? I'm just gonna try that, because you never know with GCC. Oh god, that didn't compile at all. What just happened? That's not how you write do while statements. Am I insane? What? I don't understand. Either way, this is what it came up with. Current function. Segment address, true, 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 true. Reduce pointer casting. Casting doesn't cost anything. Cache frequently access value, load once per loop iteration, reuse them. What? You want to load them before? That's just taking on even more memory throughput for no reason. But okay, yes, this is what I think it would have done, which is why I didn't give it those, because I don't want that to be done. GCC will do that by itself. Remove break after return to save OP code space. It's not, it compiles to the same thing, right? Yes. Language compile optimization, use static inlines, suggesting whether a function where appropriate. You can't, it's a recursive function. If you inline a recursive function, you get an infinite function. Wait, let's see what the difference is. OP code is W0 and FF. That's not what it is. The OP code is the first bit. You just gave me the last bit. This would not work. What else do we have? Render mode equals v1. Sure, sure. Okay, yeah, you made no differences. You made no changes except you broke the code. Cool. Toggle AA on the ASM. Why do you wanna just assembly code this? Dude, I swear. This is something new programmers say. They're like, yeah, assembly is more optimized than C, and then every time you look at someone's assembly, it's just terrible. It's just worse than the C compiler would do. Like, a compiler is smarter than, I would say, 90% of programmers. And even, compilers sometimes make dumb mistakes, but like make so many smart things as well that you would never think about. So it's like, yeah, don't do this unless you're like actually completely correct. Either way, let's move on to the next function. This one is a bit weird. Gmat stack index minus minus. I wonder if we can do something. Right, and this is something you actually want to store on the stack, because then like it caches it on the stack. Otherwise you have to read this over and over. So this is actually good. I wonder if it can improve this. I don't think so. I'm not going to waste a GPT token on this. Set up render buffers. Doesn't look very possible to do. Oh, actually, this whole computation, actually no, that will just be one value in GCC. And this will likely be in, actually this will be a mul. Mul is fine here. This is an interesting one. Maybe it can do this. All right, so this function computes an S16 matrix that represents a billboard matrix that looks at the camera. Does it have translation? Position, yes. And scale? Yeah, okay. It handles translation and scale as well as sets the rotation. All right, let's see what it does. It's fun that I only mem copy 0x38 bytes because the rest is identity matrix anyway, right? The last two entries of the matrix is just 1 and 1. No, it's 0 and 1. And then we just override this and these here anyway. So we only need to copy like half the matrix. Wait, 13 as well? And 12 as well? If I copy 12 and 13 as well, can't I reduce this to 0x30? I think I can. I wonder if ChatGPT knows I can. I don't see why I wouldn't be able to. Am I making a mistake here? Oh no, I can't, because the matrix is split in two, so all I can skip is like the last 8 bytes here from the 16s. Yeah. No, I can't. I can't. It's shorter than that. Alright. I wonder if ChatGPT will make the same mistake I just made though. Base matrix copy. Copies 56 bytes, yep. Translation component settings, yes, correct. Correct. I mean, it understands what I'm talking about at least, right? That has to be very impressive. Combine high and low rights. You can't. So nested loops for scaling the rotation matrix. Yep. Nope. Unrolling the loops gives you more code. I told you we want small code. So to keep data in register and reduce memory read writes. Like what? There's nothing to keep in registers here. Cool. This is inlined. We don't want. Actually, this might also be inlined. So no code to combined by optimization, structured scheduling. What is all this shit? It just keeps this around from the previous questions. Oh boy. What? No, that's not how it works. It's gonna set desk 12 and desk 28, and desk 12 is not 4 bytes aligned. Actually, it is 4 bytes aligned, but desk 13 is not 4 bytes aligned. So this will just crash the game. And we can't unroll this. No! US 32 writes won't work. They don't just randomly split up 16 bytes further down in memory. Also, some of those writes are not for bytes aligned and will crash the game. Also, your loop unrolls cause bigger code, which results in more data throughputs and is slower. Oh my god, this is so much text. Is there maybe something decent in here somewhere? Does it just repeat itself? This has been a bad experience so far. Yep. Just got a very funny Discord DM from another N64 hacker. Banjo Tooie is deranged. I've said this before. I'm not gonna say who said this to me. But if people knew my opinion on how well I think Banjo Tooie and Kazooie is coded, they would have my head on a pike. And this message I just received, made it even worse. God damn, that game's programmed awfully. Okay, now we're splitting into high and low, which is exactly how I've been doing it. It kind of removed the plus 16, which I thought aided readability, but readability is like, who cares? Caches the index. Is there more optimization down the line? Recommendations. Well, ensure the desk point is 4 bytes aligned. It is. It is optimized. Dude, it's just being it's being such a bitch to me. When you're trying to put away the dishes and your mom tells you put away the dishes and you're like, I don't want to do it anymore. That's how I feel with what this guy's telling me to do. Alright, let's try what it wrote here. Probably the exact same code. It's 2 instructions slower. Cool. You can tell it's 2 less from how this increased by 8. Okay, well, maybe I can do something with this. I mean, this feels like there's some smart loops to be rolled up. I feel like this could be done. This could definitely be done in a loop. Oh, yes. This is something for it to optimize. You can definitely do this in a loop. I'm just gonna tell it to do this in a loop for me if it doesn't think about that itself. All right. This next function generates a translation and rotation matrix. I don't think it needs more info like that. Let's see what it comes up with. Come on, ChatGPT. Finish thinking. All right. Let's see what this is. Always inline? No! That is way bigger. It didn't think to roll this up at all? It's mem copying the Billboard matrix? This is... Did it even understand that this is a different function? Oh wait, I went way too further. I went way too far down. Okay, never mind. Wait, no, I didn't. What is it doing? Okay, this guy just completely shit the bed. No, this is a completely separate function. Forget about the Billboard matrices and optimize my rotation and translation matrix. I don't know what the fuck just happened. Did I accidentally copy paste the wrong function? This whole train of thought for nothing? I clearly tried this. I couldn't possibly... No. Ah. Okay, so just inlined the function that was already inlined. And it said dest free to 1.f, even though our mtxf to mtx assumes free to be 1, which means this is an unnecessary write. Mole bug mitigation. Okay, you know what? It actually understood that the N60 was the mole bug. Oh wait, never mind. I put that in the comment. It knew that this function existed though. That's kind of cool. Yes, it is aligned. No, I don't want this. A plus Sx multiplied by D? Wait, what? Oh, it changed the order of operations? Okay, this is actually something it couldn't possibly know, but if I change the order of operations, like it suggests here, the mole bug gets worse, I think, right? We had 2A6C, we do this, we saw 2A6C, okay, never mind, it does make a difference, cool. Well, I guess this very marginally improved readability. Definitely not what I want though. So let's tell it to do what does more. None of this makes a difference though, right? Yeah. This is the same code. We don't need to set free because our MTXF to MTX assumes free to be 1 already. I think one optimization we can do is to roll the loop at the start of the function up and instead do 3 loop iterations to get SX, SY, SC, and so on. Let's see that. I actually think it might not be faster because this entire thing already fits into cache, and MTXF rotate CXY translate is very commonly used in actors. 99% of them this one. Yeah. So this might be a reason we do not want to roll the loop up. But I'd like to have the code for it being rolled up anyway, just because maybe in the future we add new functionality to the graph render that will require me to squish this into cache a little bit more. Besides, having this as sine vals free and cos vals free is nicer anyway. Let's see what this does. I might have done it correctly, maybe not. We definitely don't want to inline this function. 2A6C? 2A90? Oh, right. Okay. This is more, because this is an inline function that returns sine and cosine and f0 and f2, but if we actually have this be like a physical thing, like a real thing that's not just a register but like store them on stack, we're gonna have a lot of stack reads and stack stores attached to this, so that's actually bigger code. I guess that's the issue. So rolling up the loop is a bad idea for memory throughput and cycle count. Interesting. I don't think this is improvable. This is already doing some cracked stuff. Vec3 have normalized dirty, yeah, definitely not. This is the inverse square root function, but like slightly different. Vec3 have cross. I wonder if I can inline this. Probably a bad idea. Let me just check what happens here. Inline, always inline. So this will slightly increase the code size at first, but if vec3 of cross size is bigger than the amount of code is increased by 2A68, so that's 5C. Vec3 of cross is here, that's 6.4? Huh? No way. A64, yeah, it's bigger. Okay, inlining this function is actually good. That's fucking sick. Not a ChatGPT optimization, but an optimization I just found. This way we get slightly larger memory, slightly smaller memory throughput and less cycles. I should probably name this thread 9 though, because that's my convention here. Cool. Wait, I didn't actually check if the shadows render fine. Sorry, I should have done that. I need to make sure the shadows still render fine, because this function is used for shadows. Well, okay, wait, actually I should check a slope too. Let me find a slope. Okay, yeah, perfect, cool. That's That's a 2 instruction optimization. I wonder if it can optimize this one here. So this function computes the matrix for a shadow, optimize it, and I should say position and alignment with the floor. Optimize it. So far, I will say there wasn't really any improvement from the AI. I saw 2 potential improvements myself while going over this again, which is something that happens basically every time I look at this code. But yeah. I know there's a lot of AI haters out there. I'm very neutral about AI. I think it has its uses. So I don't want to just shit on it and like pretend to be part of the AI hater club to get people to like me. Fuck you. But so far it has actually not been very good. I mean, it's kind of impressive it can do this at all. I feel like most programmers I would talk to wouldn't be able to like understand this as well as I do and have like a conversation with me about it. But also most programmers I talk to wouldn't just make shit up. So there's pros and cons. Is the optimized function. It made a vector on the stack, which, okay, well, I guess I was doing that anyway with vec3fset, which is an inline function. Okay, vec3f copy, yeah, same. Scale indices? Wait, that's a crazy idea. Wait a second. That's a crazy idea. I like that. I do like this. That might just work. Although, to actually make these scale indices work, we're gonna have to probably put them into a separate array in memory. Invalid use of keyword restrict. Okay, well, that's an issue. Let's just do it without the restrict then, I guess. 2A64, 2A44. It's down 8 instructions. Let me make sure my shadow still works. Eight instructions down, dude. Yes, that's nice. Let's understand what the full difference here is. Optimization highlights. Loop consolidation. From nested loops to single loop. Raise a nested for loop with a single loop iterating over a pre-computed array of indices. Yes. That's nice. Eliminate the function called overhead. By declaring helper functions are always inline, they are inlines. Okay, well, wait, what? Well, they were already inline, so it doesn't matter. Is this inline? No, but it doesn't need to be, does it? Actually, this one does worse if it's inline, doesn't it? Let me just check that real quick. Always inline. 2A44, 2A48. That's 1 instruction more. Honestly, that 1 instruction more might actually just be cheaper. So I will keep this inline. Fuck it. Use a restrict keyword. The restrict keyword is very good, but it used it wrong, I think. I think if I do like F32 or like restrict F32 up there, it will work. Well, use of restrict. How else do I use it? F32 star restrict, that's where it goes. Like so. 2A48, 2A30? Okay, wait. pose as well. 2830, 2830 still, okay. Let me just make sure this still works. So the restrict keyword, also very good idea. It just handled it wrong, I guess. Let me actually step on one of these here. Yeah, it works perfectly. Cool, cool, cool. That's a big improvement. Holy shit. Memory alignment assurance parameters ensure the desk matrix is aligned. Yeah, it always is. Similar to person. Combine calculations. Merge-related calculations reduce the number of operations and allow the compiler to optimize floating point multiplications and divisions correctly. Why did it do that? Let me compare to the previous version again. Which ones did it optimize here? Simplified expressions. The I thing here? Is it that? Because, oh yeah, because it's like pre-computed them now, I guess. Something like that. Retain the essential temporary variables A, B, C, D. A, B, C, D. No, there's no A, B, and C. I just see a D. And for some reason it casted this to a float star first. Okay, cool. We can probably do FSU star restrict then, and maybe get another optimization going. I probably have to do this. Well, that will be wrong. This will be wrong, but we can get it to be right with no extra cost. Like free of copy here. A10. Okay, I just need to multiply these by 4, and then I should. Is it by 4? I think it is by 4. A10, 2A30. Okay, well, it's still 2A30. So I guess it does not matter. But just because it's the same and it has to restrict keywords, so there's no chance in the future I will look at this and be like, why doesn't this use the restrict keyword? I will keep it this way. Yeah, the shadow still works. That's good. That's a big optimization. That's like, what, almost 20 instructions. Wow. Very positively surprised by that. Cool. All right, so this function, this next function renders texture rectangle points on the screen. It has to compute the screen coordinates and stuff. Whatever, surely it will find something or understand what this means. Using my visual is exclusively apologizing your render coin. What? Why are they apologizing? You stupid. Did I not make it clear enough that this was going to be a different function? The compute scaling factors. Same. 640, same. This is the same. Width. XH minus XL. Oh, I guess it computes the SDX separately. with more than 0, with it's always more than 0. So you don't need that check, you just added an unnecessary safety check here. I should show this code as well so you can follow along. XL less than 0.f. Okay, 0.f is fine. Okay, same. Yeah, this entire code is the same. What is it doing here? This is all just stuff that has nothing to do with what I'm doing. Wait, it's still going? It's going about the translate rotate loops. Ah! Communication issues, clearly. Render all coins. Oh my god, this is gonna be terrible. Well, let's try it. Forget about the previous function. This is a new function I want you to optimize. This renders all the coins that are currently active in the game. Try to find an optimization. This is a long one. It has some really weird things going on here, like branches like this, go-tos, because this is actually more optimal cache-wise. I was thinking about a do-while loop here, but it is absolutely possible that the first coin doesn't exist, so we can't do a do-while loop. This is to do what? Oh, this rotates the vertices of the coin shadow. Thought for 44 seconds. Oh, there we go. What did it come up with? Nothing? Alright, please try again. Or for loop with a cap. What? It's response. Oh, now it's doing it, I think, I hope. There we go. It understood that this is like, actually, yeah, it was easy to understand, never mind. Where's memory access? And loop to compute rotated positions. Okay, let's just compare this 1-to-1. 8 xy, okay, it's already doing exactly what I was doing. This is the same. Core entry didn't change, B coins array changed to 0. It got rid of core entry. Oh, it just sets it to 0 at the top, cool. Hitbox radius squared. Okay, squaring this here doesn't make a difference, because this is all a compiler thing. Yeah. Depth range squared. Depth range squared? Okay, why is it doing that? Interesting. That could be something like here. This is usually like a linear thing that I compare to, but for some reason it's squared. Usually I just use an absf. There's no sqrtf. So that should not make a difference. The coin positions are all being set the same. It's computing dx, dy, and dz separately, then computes distance squared, which is what I do here. Distance squared less than hitbox radius squared. And num collected coins less than 3. Okay. Okay, this is the same. Determine screen coordinates the same. It gets the z pose from screen position 2 already up there. And then the h screen pose, which is this and this. It gets them all at once, and then it checks all of them at once. I think that might compile the same, but I don't feel very safe doing that, so I do not like that. Then invalid range plus coin size, okay. Render coin, the same. Invalid cache line is the same. Matrix, virtual to physical. Currency plus plus. Okay, it's the exact same function. Is there more to this? Oh my god, it's writing so much shit. Should I have just looked at the final version? Because, like, what is this? It also keeps blabbering on about compiler optimizations. Hitbox radius squared? Well, we already did that. Okay, I'm just gonna assume there's no change here, because this is all nonsense to me. This looks like it's all the same, and I'm sure it posted the final version up top. GeoProcess master list. This is the render particle stuff, yes. Definitely possible that there's an optimization here, but I don't have the energy right now to deal with that. Okay, I think this has gone on for long enough, so clearly it's capable of finding some stuff, which is cool. You have to be very expert at what you're doing to stop it from doing nonsense, though. It has some nice creativity, but like, you have to know better than it, so you have to be very confident in your skill to actually be able to use this without screwing yourself over, I think. That's gonna be my review. I hope you like this. Bye-bye. So I thought we were done, but I actually had to undo this, because the optimization ChatGPT 01 figured out here actually crashed on N64 because it calculated the indices wrong, and as soon as I fixed the calculation here, it was no longer faster. So that sucks. We're gonna have to revert this and keep going from where we left off, which is here. Maybe it can find an optimization. I mean, it was still useful to talk to it. It gave me a few good ideas to restrict. The inlines were good, although that wasn't really something ChatGPT thought of, but oh well. I'm gonna ask it to do this function next. This function appends all the master display lists by layer to the display list head, which makes everything render. Try to optimize it. Maybe it finds something. You never know. I don't think it knows that these are macros. It thinks they're functions, but that should be fine, I think. This also has all the particle code. Analyzing coin rendering, defining the loop. I feel like there is something with the G game time we can do here. Surely this is not perfectly optimized. SS patterns. A function for reference. Minimize memory access. Yes. Please go to a structured control flow. The continue statement. Let's see. Don't render. What? Wait, did I send a process object? Why is it trying to optimize render all coins? Oh, this is don't render. Did I give it render all coins? I gave it geoprocess master list. Cool. It did not understand the assignment. Optimized render all coins, but I wanted to move on to this function. That's frustrating. Spend all that time doing something useless. I don't know why it doesn't understand when I want to move on to the next function. I thought I was pretty clear about the fact that I wanted to move on. Do I need to maybe open a new chat? I mean, from this context, you would think it's a new function. Thought for 8 seconds. Tweaking particle physics. What the fuck is this? Where's my answer? His answer. You thought for 95 seconds and didn't even give me an answer? What the fuck? For all the news that are being made, like, oh, this is gonna change everything, this is dangerous, it's jailbreaking itself. It's not doing a very good job. Why is there all this header bullshit? I don't want any of this. What the fuck? Okay. Curve particle dot angles. What? Huh? It's getting. It doesn't understand that the current particle. Okay, well, maybe I should have given it this to define. Yeah, I should have let it know that. It couldn't have known what the define is. You misunderstood or... Ah, shit. Per particle does, it's a define for this. Please fix that code. Also, maybe I can tell it to omit all the header bullshit. Omit all the useless stuff about the function you are trying to. Okay, I'm just gonna stop it here. Lots of waiting with this thing. Dude, you didn't say anything? Again? It started so well. I mean, I'll give it that. It couldn't have known that core particle is defined for particle array I. That's a very confusing way I coded this. So I can't blame it for that, but the bugs with it not answering and like it giving all this useless stuff all the time. Like, what is this shit again? I don't want this. Alright, let's see what the... Why did it add process node and siblings here? Oh wait, actually that's there already. Okay, never mind. This is all fine. This actually needs to happen. Uh-huh. I guess I can move the declaration for these down. The reason these are declared here is because this was originally made with a really old compiler. So yeah, reducing verbosity, sure, good. Surely this doesn't make a difference with the compiler. It does, because now I is not declared here. 2820 still, okay. And then J as well. I will copy this from what ChatGPT told me. Still no difference, good. Alright, let's see what changes it made here. I was like, I kept the registers, yes. Okay, take these minutes by loading them to temporary variables if necessary. You know what, I'm just gonna take this whole thing, paste it in, see if it's any better. Instead of reading all this, that will save me some time. Because if it's the exact same compilation, I think we should be fine. Also, this cannot be an inline function. Why does it just assume that it's fine to make this an inline function? The reason this can be an inline function is that this is linked from a jump table. So if you make this an inline function, it will no longer work. Invalid storage class for function Neki. Oh. 2820, 29 DC. Okay, that saved a lot of things, which makes me think that it broke everything. If not, then this is an insane optimization. I don't see anything. I don't see anything broken. What? Okay, now I have to understand what it actually did here, because that would be an insane improvement. Okay, process nodes is the same, mode list is the same, current material ID is the same, ring buffer size is the same, unlikely particle despawn timers is the same, get the matrix, and age. I wish I could show both at the same time, but so far everything is the same. Else we get a temp matrix. It defines the temp matrix on the stack instead of using the temp matrix I have in memory. Does this make a difference? I want to see if the change comes from that. Because if it comes from that, then it's likely not a good change. Because having one temp matrix in memory that I'm always editing, so I can just do the floating point math on that, it's a little bit of an optimization. No, okay, that's not the change that's required. That actually increases the size. So we are not keeping that change. We can probably do a little better than ChatGPT here then. MTXF to MTX, perfect. Unroll the scaling loop for performance. It unrolled this loop here. Surely that is slower. 2A74, yes. Okay, in that case we can do way better than ChatGPT. I feel like it's probably just missing some piece of code somewhere. Current layer is the same. Buffer index is the same. Invalidate 2 cache lines is the same. GSP matrix is the same. Buffer index plus. Material ID, display list, buffer index, material ID, okay. Set prim color. Is the same. Buffer index plus is the same. G display list is the same. Buffer index plus is the same. Equals buffer index is also the same. G physics advances is the same. Multiplicator. It's getting a multiplicator here. It multiplies by 0.5 directly, which is worse. This will save one instruction, but it will load a float from memory, which is 10 bytes of data throughput compared to 4 bytes of data throughput. Meaning we lose 12 bytes of data throughput by doing this. Very bad idea. Okay, this is the same. Get sine and cosine. It casts this to an S32 first. That should be terrible, but let's just see what happens when I do that. Should do nothing actually. Yeah, no change. Cool. 1 second. Okay, just wanted to make sure I'm actually recording right. Curve particle, curve y multiplied equals. Okay, what? This is this part. Okay, that's there. That's there. Wait, this is an F32. Why is this an F32? I feel like we don't need that much data. The particle are that much data? Oh, we can optimize this to be using a lot less data. All these values are gotten from something else. But it's actually, maybe it's cheaper this way. I don't really know. Not really what we want to do right now anyway. FL drag is the same. FL drag asymptotic. Okay, yeah, I do use that everywhere. G physics advances, same. Okay, so far everything is the same or worse. So where did it save all the stuff? Render all kinds is the same. Branch display list is the same. 6 + 1, 6 circle index. G display list. Corrender buffer index. Everything is the same. Pen coins, invalidate cache is the same. Okay, this is the same. This is the same. This is the same. This is. Everything is the same. It's just missing a bracket at the end. You see that's right here. Oh, there's just one bracket instead of 2. Okay, how is everything the same or worse, but it produced smaller code? Can anyone explain this to me? Just compiled it again. 29DC. How? What am I missing? Wait, it even added this shit here. I don't want that. Still 290C, cool. I guess it can never be null. We also don't want this. Now it's 2A6C. Okay, so somehow doing the temp matrix and the loop unroll gets us way better performance? How does that make sense? There's no way it knew that. Absolutely 0% chance. Okay, let's just only apply this part. $294. That's a huge optimization for some reason. But why though? That's the entire optimization, that these are like two separate things now. I just can't wrap my head around why. I wonder if maybe because this is the same variable name as something else in memory, it's compiling to something wrong. What if I use temp matrix 2? Still 294. Also, why is there MTXF to MTX before this? That doesn't make any sense, does it? Shouldn't this happen afterwards? This should happen afterwards. This should be like this. Oh, now it's 2A7. Okay, I got it. So what happened here is, because temp matrix 2 is now a stack variable, GCC knows it can discard the state of temp matrix 2 after MTXF to MTX. But while it was a memory variable for, it didn't know it can discard this state. Meaning, while the code was like this, it was allowed to just delete everything. This is what GCC saw. And now we're back to 294. That's why this looked like an optimization, because it unoptimized something in a way that made GCC think it can just discard this now. So that was a bug in my code. And the bug is also in ChatGPT's code. But because this was, because it made one thing worse, the bug was no longer apparent. So now the bug is fixed. And now everything ChatGPT did is way worse. Cool, cool, cool. Interesting. Well, we're definitely using extract coins, so I can remove this if-def. Let me remove a lot of this unused code here, just to make... Just to make this a little easier. We don't need this anymore, but oh well. I need to recalibrate ChatGPT. Loop unrolling is typically worse. I evaluated all these ideas though and made the appropriate improvements. Now I want to move on to the next function. See if we can optimize this. Yeah, so I mean, in a way, it found the bug in my code. Or well, I found the bug in my code because ChatGPT tried to fix my code. I guess that makes it a very valuable rubber ducky. And I mean, I found some improvements while talking to it. That's also very nice. So far, across the entire video, we saved 12 assembly instructions, if I remember correctly, which is pretty nice. Pretty nice. Although none of them were saved by ChatGPT. I have to admit that. I thought it was gonna actually find things. I didn't think I was so close to perfection that ChatGPT wouldn't find a single thing. Let's see what it finds here. Man, I generally thought AI was gonna be like great and helpful, but this video is just gonna be fuel for the AI haters. Why did you know that? Sorry, again, please answer. Yeah, because it's just constantly fucking up here. I guess it can't just. Maybe my architecture is too niche. Maybe my function's too optimized. Maybe it's just supposed to work with terrible programmers. Maybe the small performance difference doesn't matter. Maybe it's calibrated to make readable code and not well-running code, because that's kind of like all the code that exists, right? People care about readability a lot more than about performance, typically. And so I would imagine that's the code it's trained on. So it just fucks my performance to... Actually, no, it doesn't increase readability. It unrolled my fucking loop. Even though I told it explicitly not to do that. Alright, let's see what we got. Certainly, I will answer your question. Dude, I told it to admit all that. Code, compute code. Yeah, I don't hate it. I think compute code is decent. 2A1C, 2A20. It's one instruction worse. Cool. Let's see if it has any good ideas in here, though. This is the same as aligned mem copy 0x38. We need that. Perspective projection. Okay. It's computing the temp matrix first and then the text vector coefficients. I can remove this if def. So it's doing this, which should be the same, but there is the mole bug on the N64, so sometimes these multiplications shouldn't be in a row. But yeah, I agree, this is slightly more readable. Scale base value, perf norm is the same. MTXF to MTX. A is the same. Yep, same. Yeah, this is all the same. Except it's using the code T. No, it didn't even use the Kotang thing. What the hell? It only used it once. I like it though. I want this. Does this make it worse? Oops. Is this what cost my one instruction more? No. Why did it not do these two though? Yeah, cool. Huh? Font object code is not a function or function pointer. Oh, compute code. 2A1C? 2A64. What the hell? That's way worse for some reason. Did I mess up somehow? Okay, I'll just remove the compute cards. I don't like it anymore. Don't have the time to figure out why that just happened. All right. Moving on to the next function because it can't find anything here. I doubt there's an improvement here. Oh, maybe there's. Let's tell it. Great job. Maybe it needs a bit of motivation. Let's move on to the next function. See if you can optimize this one. I see some potential here. Right, min distance less than distance from cam or distance from cam less than max distance. I feel like maybe there's some bit magic with apps I that we can do here. Maybe like a subtraction and then an apps I function. That could work. It just assumed it can inline this again. This is the same. Distance from cam is the same. It just made the function more verbose. Surely this will compile the same 2A1C. Yeah, cool. Cool. This is a cool thing you can do where you compare to 0 instead of comparing to iteration count. It saves one instruction. I don't think it's possible to find an improvement here. Normalize mat row. Yeah, maybe. That's inlining this up. Let me just do this before ChatGPT does anything. 2A1C, 2A34. Nope, this is worse. Okay, knowing that this is worse, let's see if it can do this. This next function here computes a camera matrix. Try to optimize this. I bet it's going to inline normalize mat row. I don't like the indices thing here. It's kind of ugly. Because, well, this does cost like 10 bytes of data throughput on one hand. On the other hand, this function only runs once. So it doesn't really matter because the data throughput just happens once, right? So there's no like throwing stuff out of cache constantly. And all that really matters here is the total size of this function, because this function is super irrelevant. Like, who cares about this function? This function, maybe I should move it out of rendering graph nodes. Oh well. Look how gigafuck this is. Optimized function. Yep. I knew it. It also wants me to not do this. See if that's better. 2A1C. Oh, it's the same size. Honestly? Okay, fine. That honestly is an optimization. But wait, it only did 3 entries? I guess 3 entries is all we need. I'm like 99% confident 3 entries is all we need, but... Cool. Okay, so... that optimization was not what we want. Because, it caused that thing to just not work. Yeah, I guess the while condition is checked afterwards. Okay, cool. Cool. So it broke my function. What else do we have? I will just... Dude, it unrolled everything again. Are you fucking kidding me? A54, that's way worse. I don't know why it won't listen to me. I just give up on everything that's loop rolled. Clearly, it cannot do those. Is there anything else that might be of merit in here? That's just an unrolled loop. Length squared. It's computing length squared and then doing the square root of it to just get length. And then, oh, it just did exactly what I have here, just in 3 steps. Cool. And that has a division by 0 check, which will again be slower. Cool. This will never be 0. The length here will never be 0. If it is, that's a different bug. Normalize macro. Cool, 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 cool. Yeah, I just unrolled all the loops. Alright. Fun. I'll copy it with the comments. Not unroll the loops. We care about data throughput only, and unrolled loops equals bigger code equals more data throughput. Let's just move on. Can you optimize this function? Question. I don't think it can. This function is completely correct. Oh wait, actually no, this is not the completely correct one. The approach as 16 symmetric is correct. What the fuck? This is gonna be way worse. Alright, 2A1C, we are going up to 2A4C. Cool. Just making sure it's just from here. Yep, cool. That's almost 12 instructions worse. Cool. Instructions where it's only one smaller size. Let's just see what it says. Thinking? Really? You're thinking? Considering what we've seen so far, I'm just gonna skip this one. This is too complicated. Okay, it came up with this now. Huh, it's just one instruction worse. It's kind of neat, I guess, but it's so straightforward that's like... Yeah. Oh, it's worse, so who cares? Maybe I can do something with this. I feel like there's some smart optimizations that can be done here. Good job. You are doing great. Can you optimize this one next? I don't know, man. Maybe it does better when you praise it. I don't know why I sometimes use int and sometimes s32. I prefer s32 because it tells you exactly what it is. Int is like... Why are you saying integer when s32 is right there? You know what I mean? You've seen that clip of Jimmy Neutron calling salt natrium chloride? That's how I feel about people that say int instead of S32. Or integer. Unwrote the loop again! Ah! Is there anything of merit in here? You know what? This looks kinda neat. It's the exact same thing. It looks kinda neat. I don't think we should set this with a loop. Is this an S32? No, it's an S16, okay. So this takes an F32, so we need to convert the S16s to F32s first. So it makes sense that we have to do this. Current mat. It gets a current mat from the gmat stack index, which is this one here. Then it's gmat stack index +1 for this matrix. Cool, cool, cool. Okay, this is honestly, this is an interesting idea. This might work. So it took all these and replaced, oh, only those two. And then it took this and replaced it with this. This should cache the value on stack, although I think it was already cached on stack before. I think these are pointers. I do not think these are pointers. Wait, it's not compiling. Invalid initializer. What's going on here? Invalid initializer. Both of them. Yeah, this is not compiling at all. I mean, I know this will work if I just like, oops. If I do this, I don't think this will be better, but like we might as well try it. No harm in it. 2A1C, 2A14. Okay, that is an optimization. If it still works, if I didn't make a stupid mistake somewhere. What's the easiest way to check translation rotation? If we go to the WinCab level, we can check it, because Mari's WinCab uses translation rotation. Actually, Mari's body uses it too, I'm pretty sure. But let's just make sure on the WinCab level. I think it's in the second overworld, and then one of those pipes. I think it's this one. Nope, that's the problem factory, so it's gonna be the one next to it. If that makes the game run better, I will give it credit for finding a 2-cycle optimization in process translation rotation. Yep, it did. Well, it might be even more than 2 cycles. Definitely an optimization. Very, very cool. Wow, those seagulls are annoying. Yeah, I'm very happy with this. Very nice. Very, very nice. In that case, you think maybe this works here too? And you meant to say, wait, not what I meant to do. This might work here as well, which would be very, very nice. I feel like GCC could have done this optimization by itself, but it didn't, and that's the point. Two A14, 2A10. Nice. All right. So we should probably do this on all the loops that use gmatstack and then gmatstack index somewhere. Do we have more of those? No, not here, not here. Right here. There could be more optimization here. Cool. Yeah, I definitely see the potential in this. All right. That's a free cycle improvement or free instruction improvement. 12 bytes of memory traffic down by ChatGPT. Yeah, it can't improve this. This is version 17 of like a 6-line function. Look at this shit. Look at what we had to do. Approach post. Nope, no chance. This one's not used currently, so I'm not gonna bother with that. This one here, that would be nice. This function is used in animations. Can you optimize it? Sure. To be fair, I had to discard like 95% of what ChatGPT said so far. But that 5%, see, I always say, when you argue with someone, you assume you're already like 90% right, and maybe they are like 80% right or something. But if you combine your 95% right, or 90% right, with the 80% right, maybe they have like 80% of the knowledge you're missing. They probably won't, but maybe they have like 1% of the knowledge you're missing. And now you're like 91 or 96% right. And that's amazing. So always listen to people and like evaluate the ideas, even if they are actual fucking idiots, because maybe what they're saying is kind of useful. All right, 2A10, still 2A10, cool. No difference. I wonder if making this a const changes anything, because this is a const. Still 2A10. Okay, well. Honestly, fuck it, why not? Same with here, this can be a const. Road trans mol. If it can optimize this one, I will be very impressed. Although this one doesn't need to be optimized because we're still going to switch to the Quaternion one. So let's just leave that be for now. Animation translation multiplier is no longer active. This is not active. You might think this should be rolled up, but this actually is a function that is used so much that unrolling this one is better. Because it does save a few cycles. Well, let's see if I can optimize this one. Good job. Let's see if we can optimize the next function. This one computes rotation matrices for animated actors. I gotta start my workout. I've been recording for so long, I can't actually get shit done other than that. I'm just gonna start. I record. Fuck it. It is bench day today. This was squats. It was 400 pounds. This was couch rate. There's 400 pounds on it. And I'm not benching 400 pounds. Especially not from up here. That's something. Let's see. I will just copy this, see if it's any better, and then move on. Again, it inlined this. You can't inline this. It's called from a jump table. A bool? Bool? Come on, man. 2A70. Okay, it made this way worse. Cool. What's its idea? Enum changed. Okay, it has an enum changed local. That's honestly not a bad idea. This might generally be better. Although you have to keep in mind, enum changed can be read in a single cycle because it's... Oops. Because it's on GP. Hmm? 1470, there's a bug. Oh, whoops. That's on me. 2A10 still. Okay, cool. So in that case, this is just bad, actually. Or actually, no. It's not. Because now we have this on the stack, and the stack is more cache available than some random spot on GP. So yeah, this is an optimization. It's a micro optimization. Probably doesn't even save 0.01 microseconds a frame. But like a few nanoseconds, yes. Post stack and road stack. Okay. It also wants local versions of these. That's not a terrible idea, I will say. It should increase that by 3. 2A10, still 2A10. If this doesn't make it worse, I think it's like if this doesn't increase instruction count, I think it's an improvement, because we are likely to have better cache availability this way. This is 2A64. Okay, that's way worse. This is still 2A64. I don't know why the road stack is so much worse, but the post stack is not. Either way, we should just leave that unused. Current mat and next mat. We already saw the power of this. The question is, where do we even use the mat stack here? Just here, just once. Okay, then it's definitely worse. Doesn't do anything. Core enum data. Or G core enum data, rather. Will this ever be better? Might as well try it. No use thinking about it if I can just try it, right? This brings us from 2A10 to 2A40. Way worse. I'm not gonna try enum frame. I think on average these are gonna be way worse. Post stack probably only works because it's like so special or something. I don't know. Core enum attributes. Yeah, I'm not gonna bother with that either. Let me just make sure it still works. The post thing has me a little bit sussy. Well then. That probably only worked because it caused the bug somewhere. I'm not gonna bother figuring out what the bug was. I'm just gonna undo it. That's a little bit more sane right now. Yeah, there we go. Cool, no improvement. Draw we J shadow. and process objects, held objects, node and siblings, root. Okay, I don't think there's anything more where it has the potential to find improvement. The next math thing here, I will try that. I think that will be an improvement. But other than that, this seems pretty hopeless to me. It did find one optimization though, right? The idea to locally cache gmat stack, that is an improvement. Now we just need that for geoprocess object. Gmat stack index is used here. And here. So this is being computed in a bunch of positions with gmat stack index being increased. Go to draw object right here. With draw object, we do not need the gmat stack anymore, meaning we can cache this value up here, I think. Right? We increase it, oh no, we increase it here. And then we use it here. So the earliest we can cache it is here. And we don't even need current mat. Oh, this is awkward. This can be G next mat. We have text rect coins. We can remove this part. Should compile the same. Just make sure. Compiles the same. Cool. No children. No children. We just subtract again. Yes, somehow increasing it and decreasing it was better. I know it's weird, but that is what it is. We increase it here, draw object, we go there. Meaning this doesn't run, does it? So I think we can actually cache it here. I don't know if we ever need current math, but just to be safe. Alright, let's see where we can go. This is G next math. Oh yeah, we also need F92 pointers. Right. Yeah, G next math or next math. This can be next math. This doesn't do anything. These can be next math. And then I need to do 4 plus, and then plus. I have high hopes. 2810, 29 AC. That would be an insane improvement if it works. That's 9 instructions. It works. Alright, I think we can credit ChatGPT with like almost 21 instructions here. Holy shit. This has been pretty cool. So just to do a comparison, this was 0x290C before, and then we divided by the 21 instructions we have, which is divided by 21 multiplied by 4. So this is a 1 divided by 2044 improvement. It's a... Am I stupid? 0.04% improvement, or 0.05 is more fair. It improved my code by 0.05%. It's kind of nice. Cool. Yeah, so my overall review of this is it can be very frustrating to work with. It does make a lot of mistakes, it doesn't really listen to you, and there are some bugs in ChatGPT itself. But actually, it's not that bad. Like, it found improvements, which is amazing. For a code that's already this optimized, to find even more improvements, that's honestly impressive. I wouldn't... Well, actually, if I had a new programmer on this project and have them look over it, I would expect them to maybe find a few improvements. But they would have to be a really good programmer for that. To actually, like, find anything, to even understand what I'm talking about. So yeah, I would say ChatGPT is like as valuable as like a mid-tier programmer. I think that's fair to say. To have, like, you know, to be in a meeting with. Obviously, having a full mid-tier programmer on your team would be a lot more valuable because you could make them do all the work and they would get a lot more done. Here you need to supervise it the whole time, otherwise it's gonna make everything worse. But yeah, that's my review. Bye!